Hi everyone, welcome to a new video of building a CI/CD pipeline for Dockerized microservices and serverless function in AWS. In this video, we'll finally start building our CI/CD stack component. So we'll start by deploying a Jenkins cluster on our VPC that we built in our previous video. So make sure to watch that video first. So the Jenkins cluster will be deployed inside the private subnets, and it will consist of an autoscaling group of Jenkins workers and a private subnet and a private instance for the Jenkins master sitting behind an elastic load balancer. And in order to scale out and scale in the Jenkins workers automatically, we'll create a CloudWatch alarm based on the CPU utilization of the workers group. Hence, if the CPU utilization of the workers are more than 80%, that will trigger a scale out event to add a new Jenkins worker to the group and vice versa. Finally, we will add a DNS entry to route 53 pointing to the elastic load balancer domain name. So before we get started, we need to build two AMIs, an AMI for the Jenkins master and the second one for the Jenkins workers instances. Hence, we'll be using Packer. So with Packer, we create a temporary instance from the official Amazon Linux AMI, and we will customize this instance to install the Java runtime environment and the Jenkins binary. Also, we will install all the necessary Jenkins plugins and dependency, and finally, we will bake a new AMI. Similarly, we will create a new temporary instance and we will provision it to install the needed requirement for a Jenkins worker, which is the Java JDK and the git command. Once the AMIs are baked, we will use Terraform to create the infrastructure based on those AMIs. So enough with talking, and let's get started. So the Jenkins master AMI will be using the official Amazon Linux image, and for provisioning part, I'm using a sample shell script. The script will install the latest stable version of Jenkins, and it will configure its settings using script written in Groovy. The script will be executed the first time Jenkins is running, and they will create a Jenkins admin user, and also they will create SSH credential for Jenkins to be able to schedule jobs on its workers, and GitHub credential so it can fetch repository from our GitHub account, and also they will give access to Nexus Docker registry. Also, the script will install all needed plugins like Jenkins pipeline and multi-branch feature, and they will apply some security patches like enabling cross-site forgery and disable remote CLI and unnecessary protocols. So by doing all of this, we will end up with a Jenkins master AMI fully configured, automated, and ready to use out of the box. And finally, we will install TrueGraph to collect metrics such as CPU, disk, and memory usage of the machine. So similarly to the first AMI, with Packer, we will create a AMI for our Jenkins workers. So the AMI will be using the official Amazon Linux AMI as a base image, and to provision this temporary instance, we will be executing a simple shell script that will install the Java JDK and the git command, and also it will install TrueGraph to collect metrics of Jenkins workers. And finally, because we are using those workers to build Docker images, we will be installing the Docker engine. So that's it, guys, for the templates that we'll be using to bake our AMIs. So now our templates are defined, all the necessary scripts. We can go to the terminal and bake our AMI. So on terminal, for each folder, type Packer, validate, and give it as a parameter the name of the template file. So now it will verify if the syntax is correct. Once the syntax is validated, you can issue the command Packer build, and once again give it the name of the template file. So now Packer will create a temporary instance from the base image and provision this instance using the shell script. And finally, it will bake our Jenkins master and worker AMIs. So it might take a few minutes to finish installing all dependencies and baking the two AMIs. So now Baker finished creating the AMI for both the Jenkins master and Jenkins slave. So if we head back to the AWS Management Console and navigate to the images section, we can see that our both AMIs have been created. So now we can create our infrastructure using Terraform based on those two AMIs. So once again, I have divided my Jenkins cluster component to different template files. Each file is responsible for creating a specific AWS resource. So for instance, this template file is responsible for creating a private instance based on the Jenkins master AMI that we previously built with Baker. I have also defined an auto-scaling group with a minimum of 3 workers. This group uses a launch configuration which describes the configuration of the Jenkins workers to be created. Here I have specified the Jenkins worker AMI as the base image. I have also used the user data feature of EC2 to make the instance join the cluster automatically. So basically this shell script will be executed the first time the worker is created, and it will use the Jenkins REST API to post a Groovy script. So it will fetch the private IP of the instance from the metadata, and also it will execute the snippet of code to make the instance join the cluster. Also, to add and remove workers automatically to my auto-scaling group, I have defined a CloudWatch alarm that will use the CPU utilization to trigger a scale out or a scaling event. Plus, I have defined a load balancer on front of the Jenkins master instance. And finally, I have created a new record and route 53 pointing to my load balancer domain name. So now our Terraform templates files are defined. We can go back to the terminal and build our cluster. So on the terminal, we need to issue the following command. So Terraform plain, and we need to give it as a parameter the variables file. So this file contains the VPC ID and the subnets IDs, and also it contains this SSL certificate. So for the VPC ID and the subnets ID, I got them by executing Terraform outbound command or by navigating to the VPC section and AWS Management Console. And for the SSL certificate, I got it for free with the AWS Certificate Manager service. So once you got your SSL certificate, you can go back here and execute this command. So Terraform will create an execution plan, and it will show you all the resources that it will create in advance. So once you are okay with the changes, apply them by typing Terraform apply. And once again, you need to give it the variables file. So now Terraform will create the resources, so it will take a few minutes to finish creating all the needed resources. So Terraform has finished creating the Jenkins cluster, and it will display the Jenkins master dashboard link. So I will point my browser to this link, and hopefully I should see the Jenkins dashboard. So here I have to enter my Jenkins admin credential that I have created while baking the AMI with Baker. So I will skip this screen, and as you can see, I have successfully authenticated to my Jenkins dashboard, and here below you can see that my 3 Jenkins workers have automatically joined the cluster. So we can also verify that the needed plugins were installed by going to the Manage Jenkins and clicking on Manage Plugins. So if I click on Install It tab, as you can see, all my plugins that I have specified while baking the AMI have been installed. And the same goes for the credential part. So here you can see that the GitHub credentials and the slaves SSH credential have been created automatically. So now we have a fully configured and automated Jenkins cluster that we built from scratch using Terraform and Baker and a shell script. So in the next video we will build our private Docker registry with Nexus to store our Docker images that we will build with Jenkins. So until then, have a great day.